Hello, everyone. Welcome back to Jump On Air. We're really happy you're spending a little bit of your Monday with us as we talk about statistics, science, data, and of course, Jump. My name is Julian Paris. I am the Learning Strategy Manager here at Jump Software. And as always, I get to be your host for Jump On Air. We have a great show for you today full of interesting speakers who are going to share some of their knowledge with us and share some of their stories. My job, as always, is to keep us on track. And so as we go throughout the show, I'll be referring to this schedule. And as much as I can, I'm going to try to keep us on track really down to the minute. And I do that as best as possible because we know your day is busy and that you may have to leave and may want to come back for a particular show. So if you have to leave, know that you can come back and we'll be starting that show on time. The link, as always, is jump.com/jumponair, which will bring you right back to our live stream. So from any device you want, your iPad, your iPhone, your Android phone, whatever it is, jump.com/jumponair will bring you right back to this live stream. Now, after Jump On Air, we hope you'll visit us over in the community to interact with our speakers, to interact with us and the show developers, to tell us what you want to see at Jump On Air. So that link is community.jump.com/jumponair. This is also where you can get to all the old episodes, which are right there along the top, and you can get to any of the shows that are your favorites. Just click the labels on the right-hand side, and that'll filter and show you those segments so you can watch the on-demand videos and share them with your colleagues. So be sure to check that out. Just a reminder about all the links that we have. Jump.com/jumponair takes you to the live stream. Community.jump.com/jumponair takes you to the community where you can interact with us. And jump.com/JOA, that's the link you'll want to share with your colleagues and friends if you want them to check out the schedule or if you think they should subscribe themselves. So 3 links to remember for different aspects of our show. All right. Now, I always like to start off with a segment, and this one is going to be Trust Me, I'm a Doctor. No, not that kind of doctor. A segment in which I talk about something I actually have some vague credibility to talk on. And so in this segment, I'm going to be talking about something of interest to me and hopefully something of interest to you that has been really a cultural phenomenon as of late. But before I introduce the actual topic, I need to tell you about someone in particular, and that someone is my nephew, Jack. So Jack just turned 2 today, so I'll be calling my brother later in the afternoon. But the reason I'm showing you Jack isn't just because I want to show you my nephew on his birthday. It's because my brother David has been doing something really interesting lately. Now, David actually is that kind of doctor. He's an anesthesiologist, and he is always very busy. So the times I get to talk to him are often when he's in his car driving. So we often talk on the phone. But lately, Dave has been calling me using FaceTime. He's actually been video calling me. Now, in part, that's potentially because Jack's getting older and he wants me to be able to see him face to face. But it's also representing a real change in our culture recently, which is that everyone is video calling. And so I want to talk about this rise of video telephony, which is really the super category of video conferencing, video calling, really any kind of video-based communication. And I want to talk about this rise, why it matters, why it's happening now, and what I think is happening next. Now, as I mentioned, I actually have potentially some vague credibility in this because even though I studied a lot of statistics and taught statistics for many years, my degrees are actually in experimental psychology. So I did research for my master's and for my doctorate really on how people understand each other and sometimes in computer-mediated environments. And that was actually how I originally started my grad school experience, was on computer-mediated communication. And I actually went digging and pulled up my master's thesis to talk about this question of why it matters. And so this is my embarrassing slide format that I had for my master's thesis. Now, my master's was research about impression formation in computer-mediated environments. So how people really make impressions, especially in these environments with scarcity of cues. So really poor environments like text messaging. And so just because I think it's fun, I'm going to keep using my slides from 2006. In the introduction to this master's thesis, I talked about these characteristics of text-only communication. And one of the biggest ones is really that there is missing information. And this is not a surprise to anyone who's ever text messaged with somebody. Text messaged, that's a weird word. But text messages actually miss a lot of interaction material that is present in face-to-face or even video communication. And so that we have some language to talk about it, I'm going to introduce you to a couple new things for you probably. The first is the paralanguage cue system. And so paralanguage refers to things like intonational contour, speech pace, and pitch. These are things that actually are imbued with meaning when we communicate. And it's maybe not surprising. You can tell if somebody has a sad tone to their voice. And so paralanguage or paralinguistic cues are totally absent in text-based communication. Another system is the kinesic cue system. So this is like facial expressions, affect displays, gestures, anything you can do with your body that also communicates meaning. And there's a lot of it. And these are the things that are recovered when you actually use webcams or video telephony. So maybe not surprisingly, these are important for communicating, which is why they exist as cue systems. So they communicate intentionality, what you mean by the words you say. They communicate emotional states, happiness, sadness, that kind of thing. Cognitive states like hesitation, and largely they serve to disambiguate the meaning of the words we use. So if I say to somebody, I'm okay, in a text message, that's a pretty poorly communicated message. There's not the paralanguage and kinesics around it that help you understand if I'm really okay or if I'm actually feeling pretty bad. Words alone communicate very little. All right, so it's pretty obvious that text-based communication is rather poor. Telephone helps a bit, and face-to-face or video conferencing helps the most. You recover most of those cue systems. And so the question is, why now only have these really caught on? And I think it's going to help us if we take a look back to the history of video telephony and think about the kind of things that had to happen in culture and society for them to catch on. In fact, the first webcam wasn't really used for communication. It was pointed at a coffee pot at the University of Cambridge in 1991. Quentin and Paul realized that a lot of people were annoyed that they walked down to the break room to find an empty coffee pot, so they came up with a system of pointing a very low-resolution grayscale camera and sharing it on their local networks. So that was the first webcam, pointing at a coffee pot. But the first commercial application came around 95, and some of you, like me, may have had a Connex QuickCam and use something like See You, See Me to actually have conversations over the internet. Of course, we had pretty poor dial-up modems at that point, 28.8 or 56K baud, and the video wasn't that great resolution, but it allowed us to see each other for the first time. Now, Skype introduced video calling in 2003, FaceTime came to the iPhone in 2010, so it seems like technology caught up with the desire, but the desire really wasn't there in large volumes. In fact, Pew Research found in 2010 that only 19% of Americans had ever made a video call. So with technology having been around at that point for over 15 years, and frankly rather perfected and easy to access, very small numbers of Americans had actually used their webcams. So what changed? Well, we all know what changed. Recently, people have been searching to actually connect out more. And so we've seen massive increases in the use of video calling. Teams found a 1,000% increase in early March. Google had 2 million new users using video streaming. Teams actually doubled that figure later in March. So 2.7 billion minutes of meetings that happened over video. And of course, we all know that Zoom really rocketed up in popularity. So what changed is that we're all culturally aware of the need to connect. And that may be the biggest reason why these things are catching on. It's now no longer very strange to video call somebody. As a society, we moved all at once, and that facilitated this transition point. So technological limitations had been fixed a long time ago. Societal limitations is what had to change. Okay, so what happens next? I don't have a crystal ball. I have given a lot of thought to these things over a lot of years. And so what I think will probably happen is that we'll start using technology like video conferencing a little bit more judiciously. Right now, we kind of use it maybe a lot because it's sort of novel and we're enjoying the fact of seeing each other. But as we grow with this technology, we'll probably start to use it in more specific ways. And so if I could be prescriptive about this, what I would say is we need to think about our communication in terms of some dimensions. On the x-axis here, from informational to relational communication. And then on the y-axis, maybe something in terms of ambiguity of communication or potential for misunderstanding. Lower ambiguity messages on the bottom and more ambiguous on the top. So if we are dealing with purely informational and non-ambiguous messages, probably an email or a text message is just fine. Those ambiguous relational messages, so if you need to have a tough conversation with somebody, turn on your webcam. You are going to do a much better job imbuing your messages with meaning if they can see your face and hear your voice. Now, on the off diagonals, we have relational communication that's unambiguous, which will benefit from hearing your voice or seeing your face. And then we have informational communications that are potentially very ambiguous, and those will also really benefit from hearing a voice or seeing your face. So I think we'll get better at deciding when to use these things, but I can tell you, I'm going to be video calling my brother later to say happy birthday to Jack. And I suspect that if you really want to reach out and connect somebody, you should turn on your webcams too. And you can trust me, I'm a doctor. but I'm not that kind of doctor. All right, so we have a great show for you today. We're going to hear from a developer again this week, and I'm really excited for you to hear from Nascif. We're going to hear from Mike again, who's going to take us through another edition of things that he wished he knew when he started using JMP. We're going to hear on a resource spotlight from yet another developer about JMP Public. We're going to have another mindful moment. We're going to hear about DOE, the tools menu. We're going to have a really great show, and so I hope you stick around. But to kick us off, we're actually going to turn it over to Mike Anderson for another edition of his things he wished he knew when he started using JMP.
Good morning, everyone. My name is Mike Anderson. I'm the New York systems engineer, and today we're going to pick up where we left off last week with the things I wish I knew when I had started using JMP. To bring everybody up to speed, last week we talked about how we are visual creatures, about how we need to consume data visually in order to get the most out of it. And this week, we're going to pick up where we left off on that. We're going to pick up on this idea of the JMP workflow, which is one of the most powerful things you can learn when you're first getting started in JMP. Before I go into that, I want to remind everybody, after I get done with the prepared content, I'm going to be taking questions from you. So take a moment, find that Q&A window, and we'll be able to answer those after a brief break when I get done with the content. All right, so let's look back at this workflow. We have started with this idea that we need to visualize our data. Well, in JMP, that's really handy because no matter where you are in JMP, 9 times out of 10, you're going to get a graph. So that takes care of this first part of the workflow. Now, what is this workflow? Well, when I'm teaching people or helping them come up to speed with this idea of what JMP is or how to first interact with JMP. Maybe they're doing a demo of the software. Maybe it's the first time I've had a chance to talk to them. Maybe there's somebody that just got it installed and they are struggling and floundering, trying to figure out where to go. Where's the first place to go? I usually teach them this 4-step workflow. And the reason for that is that this workflow covers probably 60, maybe 70% of the total questions you could ask in JMP. The first 4 steps cover that. The 5th step covers just about everything else. So let's walk through that really quick. And then I'll show you the example, through a couple of examples, how this works. So step 1, make a graph or make a report in JMP. And 9 times out of 10, that report in JMP is going to have a graph anyway. Step 2, look at the graph. If you've made a report, look at the graph that's at the top of the report. I find myself occasionally violating this rule myself when I'm doing modeling. I will stop and go, instead of looking at the graph at the top, I'll just kind of scan down to the statistics that I want. And if I'm familiar with the data, that may be okay. But in general, we always want to look at that graph first. And there's also a little caveat on this graph, on the looking at the graph part. There's a 5-second rule attached to it. The reason for that 5-second rule is because people are so well wired to see trends in data. Sometimes they're going to see trends that aren't actually there. So if it doesn't pop up, if you don't see it really clearly, odds are it's something more complex than what your graph can tell you, or it's not there and your eyes are just playing tricks on you. If you stare at a graph long enough, you will find what you want to see, even if it's not there. Okay, back to the workflow. Step 3, we're going to ask questions about what we see in that graph. And then step 4, we're going to push the answer button. There's one button in JMP that will answer a vast majority of the questions in the software. And there's a second button that's on your mouse that'll answer the rest. So let's go through and have a look at what this looks like. In this case, I'm picking from let's call it a silly data set. These are all of the Futurama episodes that were ever published. The show has been canceled, so it's a nice clean data set. I used it earlier last week to do some text analysis, and I thought it'd be fun to keep on looking at this data set. So let's start with just a graph builder of the data. In this case, I've created a graph that shows the IMDb rating by season. And I can look through here and I can see some things that are going on. I can see that there's a fair bit of variability in seasons 3 and 4 and 6 and 7. Season 5 is fairly tight. I can visually see that season 1 and season 2 were fairly tightly distributed as well. That took me about 4 or 5 seconds to do. Okay, that's how long you want to study the graph. So that's step 2. Now, in this case, in this graph builder, maybe I want to make a change to this graph. Maybe I want to do something. Maybe I want to swap out season for the writer or for the director of the show and see if there's any variation in the ratings based on that, on those factors. Well, when I look at the graph here, I don't have any way of doing that. So what am I going to do? I'm going to ask a question. How do I bring back the information or the parts of the graph builder that will let me interact with the graph again? So that's step 3. I've made a graph. I've looked at the graph. I've now asked a question. Step 3, I'm going to go, or step 4, I'm going to go push the answer button. And for those of you that are familiar with JMP, this is old hat, the red triangle. We call it the little red triangle. We call it the hotspot. Call it the LRT, all kinds of things. I call it the answer button. That is what it is. It is the answer button. I'm going to push the answer button right there at the top, show control panel, and now I'm back into where I can swap things out really quickly. So that's a really quick example from Graph Builder. Let's take a quick look at an example from Fit Y by X. Now, this is a standard report. Here I've taken and set up the same analysis that I did before. I've got the data, seasons versus IMDb rating. First thing I want to do, well, realistically, I'll fill you in on this using a little subject matter knowledge. I know that season 5 probably shouldn't be considered in this analysis because it's not weekly serial shows. It is a direct to video series of 4 movies. So it's not really, the ratings really don't mean the same thing. So I want to throw those out. How do I do that? I've just asked a question. Let's go push the answer button and find out. Red triangle. Down at the local bottom here, local data filter. And this gives me the ability to come in and pull out everything but season 5. Let's take this a step further. Now I'm looking at my graph. Let me get the local data filter out of the way there. I'm going to look at my graph and I'm going to go, okay, is there a statistically significant difference between these seasons? Well, realistically, before I do that, I have to go and check and make sure the variabilities are the same. I should be running an F-test before I run my ANOVA that I would want to do. So I'm going to say, are the variabilities different? That's my question. I'm going to come back up to the answer button. And I'm going to come down and lo and behold, right there, unequal variance. If I click unequal variance, I can see that based on different measures, I have different variabilities, different types of statistical tests. And you can go into the documentation in JMP to learn a little bit more about what each of those tests is checking. But by some measures, we are in fact dealing with dissimilar variances in this data set, which means I generally come down to the bottom here and take a look at Welsh tests, which handles unequal standard deviations. And lo and behold, down here, I can say that something in there is different, even though my variances are also different. All right, so let's have another look at some of this. Here's that same answer. I'm going to skip forward again to my tabulate here. This is an example of a report where there is no graph. What do we do with this? Well, we can do a number of things. We can select the graph. We can select this tabulate graphic and we can paste it into a PowerPoint, or we could turn it into a new data table. Well, how do we do that? I just asked a question, right? So we're going to go to the answer button, and down here, make into data table. And it spits out the data as a data table. And this helps you, again, bringing back the point here, JMP is set up in a kind of almost a Socratic method. It's designed for you to ask questions and then go look for answers, not necessarily to go after specific statistical tests, but to follow that train of inquiry that you normally would in your head. And again, we do that using the 4-step workflow. Make a report or make a graph, look at the graph, ask a question about what you see, push the answer button. Well, what happens if you can't push the answer button? Or what happens if the answer to your question isn't part of the drop-down menu in the red triangle? What do? Do we give up and go home? No. We use the other answer button. And the other answer button is the right click. Or for Mac, it's the double click if you want to call it, but right clicking on the window. In this case, if there were questions that I wanted to answer in here that couldn't be answered under the red triangle menu, I can go in and right click on the graph, and I get a whole list of other things I can do. For instance, if I want to change the marker size, I can come down and I can make that larger. If I want to color these, how do I color these data points based on well, let's see what we've got for options. I forget what we've got in the data table, but if we wanted to color it based on something, we could turn on the row editor. We could look at what they were based on the number in the season. So which episode were they in the season? We can click OK, and we can color it that way. In this case, it makes a kind of a crazy graph. But again, the point being, click the red triangle. If the answer's not there, right click. The answer will probably be there. And that's what we're going to cover right now. So we'll take a 2-minute break. Julian will set up a timer here in a second. Go ahead and put your questions into the question Q&A section, and we'll come back in 2 minutes and I'll start answering those questions. So Julian, 2-minute timer for me, please. Thank you, Julian. We did have one question come in. Again, if you're going to be doing, if you don't want to ask a question, go ahead and put it in the Q&A. The question that came in was, if you have a graph, how do you then add a value label to each point in the graph? And then also, how do you move the value label around and change the font size? Okay, well, that's a great question. Let's go ahead and, in fact, we're going to start with a new graph builder. What I'm going to do is bring over a little bit of both here. So I've got the data table, and then I've got a graph window over here. And I'm going to start with a fresh graph builder window, just to show you what it looks like. Let me move it over. There we go. Looks a little crazy at the moment. It'll resize itself when I get going. The way that there are two things that you need to do, or two ways that you can label things in graphics. And one of them you've actually seen, you can see right here. It's this little tag next to the column name. If I come into that first graph that I created and I hover over one of the data points, notice it gives me the title right here. That's because I've told JMP that when I do a hover, or hover over a data point, I want to see the particular set of data. So if I wanted to also add what season it came from, I can right click, say label to get a label again. And now if I come back over to the graph, it tells me what season it is, not just what table it is, or not just what the episode is. And then the next follow-on question is, how do I automatically show those every time I get this set up, every time I set up a graph? Well, there are two things you can do. And actually, I'll use this first graph before I go into the other. If you want to show a data point all the time, you can come and pin the data point. And from there, you can move it around however you want. You can do all kinds of stuff like that. Okay. That's one way of doing it. If you want JMP to always label what's going on at your data point, and in fact, I'm going to turn off the label for the title, because otherwise this is going to get really crazy when I do this. Let me move this out of the way just for the moment. If I were to, for instance, let's create this, actually, let's do the directed by. And then we will do the IMDb rating. What you can do is, back in your data table, if you want them to always show up, you can select the rows that you want to label. And you can right click and say label unlabel. And now those rows are also labeled. In addition to, or the rows are labeled and the columns are labeled. So when we come back to the data table, everything that's season 1 is labeled. Now, adjusting the text for that, usually I like to come in under File, or excuse me, under Preferences, and I will come into, where's my fonts? There they are, down at the bottom. And one of those is the marker label, I believe this is the one you want right here. Another thing you can do is, I think there's another way to edit this. It's not coming to mind right away, but there might be another way to edit this as well. If you look in the community, I think there's a question on how to do that. So if we go to community.jmp.com and search for axis label or value label editing, it will also show you those other ways of doing it. Okay, and then the next question is, how do we make a bar graph with 2x2 parameters with different color and with standard deviation? And the question here is, they followed up, I have 2 seasons, each has a treatment and a control. Okay, that's a fun question. Let me clean up this mess here really quick, clear row states, and I'll start over here really quick. So if he's got 2 seasons, we can do this a number of different ways. I'm going to break this up really quickly. And in truth, it's just dragging and dropping. So here I've got directors. Now, if I want to break these up by seasons, there's that. And I can turn these into graphs. And this is going to look truly awful because of the screen resolution. But just to show you the mechanics of how to do it, IMDb rating. And let's put a local data filter on here to filter out the weeks. Let's just look at the first 2 seasons, or filter out to the first 2 seasons. And then from here, let me get this out of the way. It looks a little crazy, but what we're looking at is the average score. We can also change that to the sum, or to the mean, or we can change it to the standard deviation. If you want to do a second statistic, you can split the screen again. And in this case, I can do standard deviation versus the mean. Whoop, that's the median. The other thing that you can do is also turn on the error interval that will put a little error bar on top of the standard deviation. And you can see right here, it's a little tricky to see, but there's a little error bar on top of that now. And if you want to do with different colors, all you have to do is drag, instead of it being across the top, it can be across the side, and that gives you the way to do that. Okay. All right, Julian, we're about up to time, so let me just close up here really quick. We'll be back next week, and next week we're going to be talking about why the Analyze menu is loaded the same way that it is set up the way that it is. So if you've always wondered about why the Analyze menu is set up the way that it is, join me next Monday for another What I Wish I Knew When I Started Using JMP. Julian, back over to you.
Thanks so much, Mike. Yeah, and again, make sure you interact with us in our user community, because if there are additional questions you have for Mike or things you'd love for him to show, or even about the topic he has next week, things you'd especially like and you want to get your question in early, make sure to interact with us at community.jmp.com/JMPOnAir. In our next bit, our next segment, Mary and Pete are back to act out real-life scenarios where a JMP tip would actually be the solution. So turn it over to Mary and Pete again for the tip of the day.
Now, hey, Mary, this is the JMP On Air JMP tip of the day. And Mary, you told me you have some cool stuff to show me that on how to deal with date timestamps and recoding them and making new formula columns.
Oh, yeah. Oh, wait till you see what I found. And you know how much I dislike converting dates, right?
Right.
Let me share my screen with you. And, right.
So is this like some of the stuff you learned from Mark Bailey?
Oh, yeah. This is Mark saying, don't send me any mail.
Okay. So Mark.
Yeah. So I have this data. I'm looking at solar data, right?
Uh-huh.
And so I want to look at power. I'm going to bring the date time here. And I look at this and I go, holy moly, look at this date time format. And you know, this stuff just drives me nuts because it clutters everything.
I'm glad you made it PG there, Mary, and it was
Yep.
holy moly. Okay.
So by right mouse click, I get all of these options under this column formula. You can see I can transform, I can aggregate, but look, I get date time, and look at all the options that I get for date time.
Oh, cool.
So I'm going to do date time, and I want to do day, month of the year. And I want to, and you notice it creates this variable here.
Oh, nice.
And I can put it here. I'm just going to do this, and I'm going to take the jitter down. So now you can see I have this nice graph of points, and it's not so overwhelming. So
wow.
Then, in the true Mary sense, I kind of got carried away, right?
Uh-huh.
And I'm looking at these other things, and I'm like, wow, you know, I could maybe pull over and do some color here. And I'm like, maybe I want to do the ratio of power. Let me do ratio of power to irradiance, right? So
Okay, yeah, that makes sense.
If I right mouse click here and go combined, look at, I can do the ratio. And this is all on the fly. But
that is so cool.
I can put it here, and then if I want to come down in month of year, and then let me go date time. I'm all into date time, right?
Yeah, that's great.
Let's do time of day. Put this here. Look at this. Right from this graph, in a matter of a couple seconds, I have this peak of time of day right here between 6 and 10, and this ratio. And I didn't have to do any coding, but what's nice is I can right mouse click, and it says, do you want to add this to the data table?
Oh, so what does that do? Does it, what do you
Yeah.
get out of that?
So if I right mouse click here and add this to the data table, it actually creates the formula for me.
So,
Right there.
oh, wow, that's so easy. I love that.
Code for me. I'm like, you know, I'm pumped because date time stuff and then the power radiance to ratio. So I get to use this column formula. If I come here and we right mouse click, you can see new formula column. It's the same thing. And in all the platforms, like I just showed you, you can actually do the same on any variable. I went into temperature. I could then, and it recognizes it. You know, it doesn't say date time here because it's not date time. So anyhow, this is a
That's great.
win. This is a win. So I'm going home now, and I've done my excitement for the day. What do you
Great.
think of that, Pete?
I think that's wonderful. I think Mark Bailey might have put that in the software just so you'd stop calling him.
I think he did. I think he did. Shout out for Mark.
All right. Okay, well, thanks. And this has been our jump tip of the day.
Great. Thank you so much, Pete and Mary. Again, if you have tips you would love Pete and Mary to share and act out, make sure you go to their episode pages and leave a comment, and they can take us through your tip in their acted out scenarios in the Jump Tip of the Day segment. Okay, our next segment I'm really excited about. Another one of my absolute favorite Jump developers is here, Nascif. And again, Ann Milley is going to take us through an interview with Nascif, and he's going to tell us a little bit about what he does at Jump and what he does in general.
We are pleased to be featuring principal software developer Nascif, who has a beautiful last name that I'm going to ask him to pronounce so I don't butcher it. But Nasif's eloquent code makes things more beautiful and more useful in Jump. Welcome, Nascif.
Thanks, Andy. Thanks so much.
So could you start by please telling us a little bit about yourself and how you pronounce your last name?
Okay. So my name is Nascif Abousalh-Neto. This last name has a bit of a history. I'm originally from Brazil, where we speak Portuguese. But like the US, it's a country of immigrants, and my grandfather is from Lebanon, and he asked my mom to give me his name. So Neto actually means grandson. So even though I'm from Brazil, my name is actually Arabic. That's why it sounds so different even to Brazilian speakers too.
It's beautiful, lyrical.
So I was born and raised in Brazil. I went to college there. My background is in software engineering. I came to the US about 25 years ago. I worked in telecom before I moved to SaaS. I'm 15 years with SaaS. I work total, right? So I work in solutions, BI, even visual analytics. I was both a developer and a manager for a while. And during that time, I was already using Jump, because I always like to use data analysis and visualization. At the time, my gig was like code metrics and software quality, right? And Jump was so easy to use, it was great for that. 5 years ago, I had an opportunity to join the team, and I've been with Jump since.
And we're so happy to have you. So can you tell us a little bit about what areas that you work on in Jump?
So my main responsibility in Jump is hover labels and annotations. Within Graph Builder, but also all the graph components used by the many platforms we have, right? So if you think about Schneider's mantra, right, that you should, and I am cheating right now, overview first, zoom and filter, and then details on demand. I do the details on demand part, although now, as we're gonna see with Graphlet's, a little bit of the filtering too. And the other project I worked for a while is the Formula Depot, and in particular, the part of code generation, and that's one thing that enables model deployment, which is a very exciting thing too.
Nice. Well, thank you for sharing what you've been working on. And now, of course, we want to see some. So could you show us a little bit?
Of course. All right, let me share my screen here. Is it sharing?
Not yet. Oh, here we go.
Okay, not this. No. So I wanted to start, I'm going to talk just a little bit about the Formula Depot, and then I'm going to show you most of the stuff about the Graph Builder. And all those things, I have plenty of posts in the community if people want more detail. So Caleb wrote this really cool blog post talking about modeling COVID. And he finished after creating a model. He had this corollary here. Maybe we can call it the law of Caleb that it's right here at the end. A model is only as good as its ability to predict beyond the data, right? And well, true, but I would like to extend that in that a model is only as good as its ability to predict beyond the data at the place and location where that prediction is needed. So, for example, let's say that the US government asks JMP to say, I want to create a model that allows me to decide if someone needs to be tested for COVID or not, right? That's a very critical thing. And let's say we come up with the best model possible. And then turns out, okay, fine. Now I want to give this model to every nurse in America. They need to be able to use it at the hospital as soon as the customer comes in. So probably at this point, what you need is to get this model and put it on a website or maybe an app or something like that. But definitely it's not going to be running inside JMP. You need to put it out there, right? And JMP Pro can do that. Let me get back to JMP here, and that's where it gets fun for everybody, right? So I don't have COVID data, but let's say I had this diabetes data set. Many people are familiar with that. And let's say I generated many different models, and I came up with the conclusion that this bootstrap force is the model that is going to answer the question for us, right? Well, I can come here, and this is the formula depot. You can find here under the Analyze Predictive Modeling button, and you can create one from here. But typically, people will create those models by going to a model. Let's say I go here to diabetes, and I do a click decision tree. And on this guy here, I'm going to have under Save Columns, I have Published Prediction Formula. That if you don't have a formula depot, excuse me, is going to create one and put the model there, right? So, but let's go back here to our formula depot. Here I have the options to generate code. That was my contribution. You can generate C code if you want to put like an embedded thing on a device, maybe on a phone. You can generate Python code. Let's say you want to put it running on a web server, and then you can update it very quickly as the model evolves. Or you can even generate JavaScript and put it on a website, right? So I can just point to a web page and my model is running there and give me results, right? It's not very interesting to see, but you can tell that those models can be very complex, and it's not something that you want someone to have to translate by hand from JSL to a programming language, right?
Right.
So SAS takes care of that for you. And that's it for model deployment. I really want to focus a little bit more on the other work that I do, which is hover labels and graphlets. So hover label is basically once you hover over something in a visualization, you get details on demand. So right here, it's telling me, well, that particular bin on this histogram corresponds to a particular range, a particular age range, and has 51 people on that. That's the count. And that's nice, but could we add more stuff to that? Could we add more information? And with JMP 15, we can. So this is a graph from that data site, from that same data set. But now when I hover over that, I have both a descriptive text, which is something that maybe a non-statistician can look at it and immediately understand what's going on. I have an embedded visualization, even with a reference line, so I can see where that particular point falls on the overall distribution, right? And this guy is using a lot of customization to do. I'm showing it most to show that it's possible. But just to show you the things you can do, going back to this guy that was very simple, I can come here on a, let's say, fit X by Y, right, and say, well, it would be really cool if I could see this distribution here associated with the bins that I have on my histogram, just to compare between different age ranges, right? So I come here and I save that script to the clipboard. So I'm saving, it's almost in a way the representation of the graph. And I can come back to this guy and just say, click on the background of the graph, right? Now I have hover label, paste graphlet, and behold,
Nice.
that particular fit by Y distribution for the different age ranges. And I can even let me get one. So that was an older guy. Let me say if I'm here on a younger thing, I can see that, you know, my fit is quite different. So I went from, I'm now able to do something that's very important on that exploratory workflow that Mike talked about. Sometimes you don't want just one visualization, but multiple visualizations that you can compare. Maybe
Yes.
aha moment comes not from the particular visualization, but by comparing different ones.
Right.
And we're making this very easy to do with graphlets. One thing also that we can do, so here basically it's on the hover label, it's a thumbnail and I'm pinning it and it's pinned to the graph, but that's more, we can do a lot better than that. If you click on the thumbnail, and let me move it here to the side. And by the way, I'm using projects, and projects work beautifully. I don't need this guy anymore. With this graphlet ability of launching visualizations, because I'm going to be generating a lot of visualizations, but projects is going to keep them organized. So back to my original guy here. The fit by eye, partition, distribution of age. Yeah, here's my distribution, right? So you see here, I have my two visualizations, one on top of the other. I can even, let's say I don't care about, and after, let me take this down. Okay. So, I'm comparing different age ranges. By the way, this is a fully functional visualization. I have my graph builder. I can come here. This not a graph builder, but could be, right? But I can do all the manipulations I usually do. So I have a fully functional local data filter, and that's the range that came from the graph. And I can come here and adjust it, and the graph is gonna go away. So I can come here and make changes, right? And keep exploring my data any way I want, using all the advantages of SAS. They're not static images, they're fully functioning graphs. Even better, if I go back to my original graph and say, okay, I don't want to look at that 30 to 40 range anymore. I want to look at a different one. If I control click on the thumbnail, it's gonna replace the visualization that I generated. So there are keyboard modifiers and a lot of ways where you can create a workflow that allows you to both quickly create visualizations, but also control and manipulate them, right? Always to support this, get filters and compare to find new insights.
Wow, that really facilitates the discovery process, and you can just follow whatever interests you to answer all your questions. Brilliant. How did you come up with that idea, or did customers say, hey, they want to be able to discover things faster?
Well, one of actually, a lot of it goes back to PenU, although I was already thinking about how could I make the hover label more useful, and building JSL to generate images was one of the ideas, right?
Okay.
But one of my colleagues on the stats team, she had on her particular platform, she wanted to be able to hover over a point and see a visualization that she was already launching, but by doing a lot of clicks and say, you know, I just want to hover over and get this back. So there's this meeting of minds where I had a vague idea and she had a specific use case.
Well, I love it. And it's so consistent with the JMP development theme of removing unnecessary clicks and facilitating the discovery process.
Absolutely.
Thank you so much for sharing that. Well, let me ask you this. What is it like, you know, for you to have created this, to have written this code, this underlying code that enables this kind of discovery, and then watch someone use it?
Oh, let me show you something that really exemplified that, because one of the things I was really happy was, I mean, just talking a little bit about how it was implemented so that you understand. The goal was really to make it easy to use, but I also wanted to expose the internals of it so that I and other more, you know, expert users could build their own thing. Because even if you have this okay, maybe you want to see a bar chart, and there is something I call preset. Let me just show it to you real quick.
Thank you.
Back here, right? So let's say this is a data set, which is, if you're familiar with the Unscombe quartet,
Yes.
this is where, you know, you see all those different categories, right? And they all have the same mean and the same standard deviation. That's what this graph is showing. It's not very useful because it's all the same. I can't really compare, but I can use graphlets to kind of see, well, the distribution inside those guys is completely different, right?
Right. I love the jump man.
But let's say that instead of using that distribution, I want to see something like a heat map, maybe, right? So you just by clicking, it runs something I call a preset, which is again on that spirit. Let's make it as easy to use as possible, right? But sometimes a user will come with a request that is completely different than anything you have thought about, or it's very specific, right? So for example, we have had many users, no, it's back here. I'll just come back. I apologize, I'm a mess.
That's okay.
So this data set came from an SE guy that I was collaborating with, and it was a map of the United States. And on the table, you have pictures of the United States representatives, right? So by default, if you don't do anything just out of the box, JMP is gonna look for the first image that's labeled, and it's gonna put it on the hover label. But if you're from a big state like Texas, right? And this guy here is much better. So I have one representative here. Oh, actually, I like to give this demo with Kentucky. No, that's Alabama. And there you go. Tennessee. Let's take Tennessee. I have, or North Carolina, even better, because that's our state here. So I have many different representatives, right? But only one picture. In fact, I can tell you that we have, and again, I'm using a preset, but it's a non-graphical one. We have 13 representatives. So showing just one picture is kind of like, you know, that's not satisfactory. So I built an add-in using that second layer that's JSL based, that the user doesn't have to use if he doesn't want to. That basically goes over all the data set, finds all the columns that have pictures, right, and creates a viewer. So now I can go back to North Carolina and it gives me a sample of my representatives. Because you don't want to show everything, it could be 1,000, right?
Right.
I can click here and I can page and see more of them.
Nice.
And I can even see multiple ones, right? Now, the really cool thing about this is that this is working on 15. It's not 16 code. So I can create something and give to customers right away and they can start taking advantage of that, right? And so I published that as, and of course, but this is gonna become not an add-in, but a feature in JMP 16. Now I posted that to the JMP community, which is where I wanted to get all the way. And it's just, got it. It's just the curator photo. Yeah, I think that's the one. So I posted the community, and this guy downloaded and ran it on his own data. He was there generating semiconductor wafers, right? And he wanted to look at code quality, but every data point had multiple pictures, and he wanted to see all of them. So he was able to use that stuff, this add-in, which is based on graphlets, to get it right away. And he posted the screenshot in the community. And this is one of the things that make your day, you know, to people, see people getting the stuff you did and immediately getting value out of it. So that was very cool.
Absolutely. Great. Thank you for sharing that, and that there is an add-in available now for people that want to use it. And oh my goodness, the possibilities are endless with just these few examples that you've shown. So hopefully that will motivate some of our viewers, and hopefully you'll get some more feedback.
I sure hope so. There is one more example.
Okay.
So if I have time.
Good.
Just have time. So, and that's also in the community as well. It's just that all those windows are one on top of each other. I have to do a lot of navigation here. This is something I also posted. This is an example that showed at JSL level, but it's really simple in terms of what you have to do. This is all at the end of the day if you use the code I posted. But let's say that you have a data set which doesn't have all your data, right? For example, let's say I have a data set that many people are gonna be familiar with, the iris data set, right? So it's colored by the subspecies. And so I can say, okay, green is versicolor and red is setosa, and they're kind of clustered like that and stuff. But you know, there's a lot of information about those flowers out there in the internet, for example, in a Wikipedia. So what if I went back here to this graph, and I'm gonna run the rest of it. And now, when I look at those guys, and those points representing flowers, I can see actual pictures of them.
Oh, lovely.
And I base not only images, right, but also a little bit of text explaining them. And those two things are not on my data set. I'm taking advantage of JMP's ability to make REST calls, and I'm taking them from Wikipedia. So I'm basically augmenting my data in context, right? And that's something I'm also doing using Graphlets.
Very nice. Thank you for sharing that. I love how it can combine data and visuals and data exploration. So it puts everything in the context that you want.
Yeah, I think that's the whole trick, was to find that the visual element creates a context and taking advantage of context. That's exactly, that's a very good description of what this feature does.
Perfect. Thank you, Nascif. This has been great to see. Well, can you tell us something unrelated to JMP that you're highly passionate about?
Well, one thing I love, but for many reasons I was not able to do for a long time, is the stand-up paddleboarding. I have a paddleboard that's on my garage, is just getting dust. But now that, you know, that spring is finally here, and hopefully they won't close the parks, but I'm looking forward to go back to Lake Jordan. And, you know, that's the perfect form of social isolation, is just be on a paddleboard in the middle of Jordan
True.
Lake. Nobody's going to be close to you if you don't want it to.
Good. And it works on your balance and all kinds of other things.
Great exercise. And
it's great.
Very relaxing, you know, it's kind of like meditation in motion, really.
Yes, I'm reading a book called Blue Mind that talks about how it's really healthy for you. It's good for your mental health to be in, on, or near the water.
Oh, cool.
Yes. So cool. Have fun with that then. Well, what is something that most people don't know about you?
Don't know how we are on time, but I'm going to make it real quick.
We have a little bit of time.
A little bit of time, that's cool. So I went to a park a few years ago, maybe 3 years ago. This is in a park in Brooklyn. And I was taking my nephew there. And I was fascinated by this little guy. This is basically a climbing thing, because of the symmetry of the arrangement of the cords inside of it. And I did a little bit of research. And it's actually this 3D polyhedron. It's called a truncated octahedron. And one of the cool things about that is that not only it tessellates a space, you can create partitions in space with no open spaces, just using this guy, just like you can do with a cube. Mm-hmm. But you can do that with two colors, right? Without, and in a very interesting pattern. And the other thing that you can tessellate space, 2D space using two colors, is a chessboard. So that gave me an idea to create, and I'm going to take a risk here. I'm going to move my camera. If you can see that.
Yes.
So I used that geometry to create a new 3D chess variant. That's not the one they play on Big Bang Theory, right? It's something else. So those are planes on that tessellation, and you basically play up and down across the directions that you would have on this little guy.
Wow.
Now, the problem is, this is the only board in existence in the planet, and I was planning to take it to SAS to play with the chess club over there, but I can't. So I'm gonna wait a little bit, but eventually, if anybody looks at that and finds it interesting when this whole thing goes out, you know, just hit me and maybe we can play around or two.
I hope that comes soon for you, Nascif, because it looks very cool. So creative. Well, thank you so much for taking the time to be with us and share. We really appreciate it. Very cool stuff. Keep up the great work.
My pleasure. Nice talking to you.
Thank you. Julian, back to you.
Thank you so much, Anne, and thank you so much, Nascif. I look forward to losing at that 3D chess to you, Nascif, at some point. Very interesting stuff. Well, I'm really excited that our next speaker is also a JMP developer who's joining us for our special resource spotlight, and he's going to be telling us about JMP Public.
Hi, so in today's resource spotlight, we are going to be talking about JMP Public. JMP Public is a fantastic open space that we offer for you to explore some relatively new JMP functionality. I'm Damien Carville, I'm a sales manager here at JMP, and I'm joined today by Michael Goff, a developer on our JMP Live team, which is the team which also brought JMP Public to life. So Michael, can we jump straight in? Can you please tell me what JMP Public is and who it's designed for?
Yeah, so JMP Public is an online platform where you can share your statistics and visualizations created in JMP with other people online. JMP Public, of course, is a public-facing instance of JMP Live, which is the newest product of our JMP lineup, enabling JMP users to share their discoveries with the world. So right now, I'm on the first page you see when you're visiting JMP Public, the featured page. The featured page includes posts that we want to highlight for everyone to see on JMP Public. Right now, we have a lot of great analysis, including the latest with the coronavirus, along with some other more lighthearted reports.
Cool, some pretty cool stuff to look at there. So what was the thought process for you and the team behind the concept of JMP Public? And then you've mentioned something JMP Live. Can you also clarify the relationship between JMP Public and JMP Live?
Yeah, of course. So one of our biggest requests with JMP was to create a way to help users share their reports with others. So, after building some interesting reports in JMP, we wanted to provide an easy tool that helps share your findings, even to those who may not have a copy of JMP available. We do have some tools for sharing reports, but we wanted to build one with the power of JMP built in, so you can review reports interactively and update your reports live, just like you can do from within JMP itself. So the solution for that is JMP Live. So as I mentioned before, JMP Public is just an open version of JMP Live where you can share your data with everyone, which is great for people who want to share their interactive reports and findings with anyone in the world, including those who don't have a copy of JMP available. So JMP Public is great for testing out the functionality of JMP Live. But if you want to share private data within your own company, you might want to look into JMP Live for sharing your data securely.
Very cool. Thank you. So I personally have been speaking to a lot of customers about JMP Live. It's getting an incredibly positive response out there. We're very, very excited about it. So JMP Public, how do you personally use it? Do you have any examples you can show us?
Yeah, so when you sign into JMP Public, you're taken to your dashboard feed. The dashboard feed is a place that you can tailor the post to you. So this is including people that I follow and groups that I'm in. So I have some posts from Dan and Byron and of course myself. But also you can publish your own reports from JMP, which is what I have here. This is a data set of songs that my phone hears. I have an ambient microphone running on my phone that logs any song that I hear out in the environment. So let's take a look at that. So here I have a folder of these reports, and we're going to focus on this packed bar of the artists and look at a local data filter with the genre. So here I have, I listen to the radio a whole bunch, so I have a whole lot of like pop-related music. So don't judge me for the contents of this list, but we have so we can look at this report, and I can click on this local data filter, and you'll notice that the graph itself changed. We went back to the server, which is hosting a copy of JMP, and it's powering our live report here in the web. I have this great report, and I might want to share it with some other people. So you can do that with JMP Public. You can hit share, and we have a couple social media options to share with. This one is LinkedIn, so I'm going to share this post with my connections on LinkedIn. So I can type something up here like, hey, check out this post on JMP Public. and then hit post. And that post was shared with my connections on LinkedIn. So that's just one way you can share your reports on JMP Public.
Wow, that's pretty cool. So I'm going to throw you a curveball here. So you obviously disavowed the music collection that we saw there because of the passive listening of your device.
That's
who
right.
Who would have been at the top if it was your selection?
Let's see. I've been listening to a lot of Monsters and Men lately. Fun, Mumford and Sons. Yeah, that's what I've been listening to a lot recently.
Pretty good stuff. Good stuff.
Yeah.
Mine would have been Talking Heads, and then probably some English music from the late 80s and 90s. Oasis, maybe. Stone Roses.
Very nice.
Good stuff. All right, Michael. So I have a question for you then. So if I like, what you've shown me here today, and I want to take a look at JMP Public and consume some of these reports, or even let's say I want to publish some of my own, how would I go about doing it?
Yeah, so if you want to just look at JMP Public or the featured posts, all you need to do is go to public.jmp.com. If you want to create a personalized dashboard for yourself or to publish your own reports, sign in with your SaaS profile, and you can publish reports by going to File, Publish from JMP itself.
Very cool. It's pretty easy.
Yeah.
So there you have it, everyone. Today's resource spotlight of free, fun, and open JMP report repository, JMP Public. Back to you, Julian.
Thanks so much, Michael. Thanks so much, Damien. Yeah, definitely check out JMP Public, public.jmp.com, and we'll be sure to link to Michael's post that he just put in today's episode page. And be sure to give a comment, if you would, on his post or on his page if you have any thoughts on his music selection. All right, our next segment is Phil K. coming back to tell us why DOE, and his second reason, process understanding.
Well, hello everyone. So this is the second in our series talking about why you should be interested in design of experiments. Today we're going to be talking about the second reason why I think you should be interested in design of experiments, and that is process understanding. I'll be answering these questions that I've given myself. Let's talk about why I wrote this blog series in the first place. We'll recap that. We'll also recap what we talked about last time in the first of this series. We talked about a case study, and I need to tell you a bit more about this case study, which is how we actually measure how successful each run of our experiment is and what the response is. So that's going to be one of the terms that we'll be talking about today. Then the main theme of this really is how we can use our data from experiments to better understand our process or our system. And then we'll talk a little bit about what we'll learn in the next series as well. Just to remind you why I wrote this blog series, well, first of all, because I love design of experiments. I think it has huge value. I think if you're not using it and you're a scientist or engineer doing experiments, then you're probably wasting a lot of time. What I really wanted to do with this series was to demystify design of experiments with some simple explanations of some of the terminology which can be a little bit confusing for people when they're learning about it for the first time. Through this, what I want is for you to see that there are only really very good reasons why you should use design of experiments. It's not magic, it's a science. So what did we talk about last time? Well, we introduced a case study that we're using throughout this series. It's a case study about testing for water quality. And this is putting ourselves in the shoes of an analytical chemist that has to develop a method using gas chromatography mass spectrometry in order to test for trace level contaminants in water samples. They use something called a large volume injector in order to do this. And what we saw last time we learned a little bit about this large volume injector. And the key thing was that there are really a lot of different factors when looking at how we could set up this large volume injector. There are a lot of different ways that we could set this large volume injector in order to make sure we get the best measurements. In fact, there are 8 different key things that we can change. Things like injection volume, injection speed, injection temperature. There's different types of liners that we use within this instrument. There are different settings of venting as well. And what all this adds up to is that there's an overwhelming number of possibilities. When we think about all the different ways that we could set up this large volume injector, if we consider each of our factors, each of these things that we could change, and we consider that we might want to change each of them on 3 levels. We might have a low, medium, and high setting for each of these factors. Well, if we think about all the possibilities, then we found out actually that there are more than 4,000 different possibilities for how we could set up this large volume injector. And we've got the challenge of working out which one is the best. Which one gives us the best measurement of trace impurities in any water sample that we might need to analyze in the future. Briefly, I introduced that ultimately what I'll be showing you in this series is how we can solve this problem by looking at a much smaller number of these possibilities. If we consider this possibility space, this opportunity space, actually we can just take 26 of the possible combinations of these 8 factors and learn enough about this process, this system, to solve our problem. So that's a recap of what we talked about last time. Let's move on to talking about responses. The response or the responses, that's one of these technical terms used in design of experiments that we need to explain. The response is the outcome of our experiment. It's a measured outcome of an experiment. It's the thing that we care about at the end of running an experiment. So in this case, we said that what we're trying to do is come up with a method that gives us the best measurement of trace level impurities in water. What that means is that when we get our gas chromatogram out at the end of this, this process of measurement, we want the peaks, and each of these peaks represents a different substance in the water. We want the peaks to be as tall as possible, as strong as possible. We also want them to be clean and symmetrical. So what we're looking for is really tall peaks here. What we're going to be talking about as our response for this, in this case study, in this series as a whole, is the sum of all peak heights. So each peak represents a different analyte, a different substance that we're trying to analyze in this, this sample. What we want is, when we add the peak heights for all of those together, we want that sum to be as high as possible. So this is just looking at the first 10 or so runs of our experiment, this big experiment with more than 4,000 runs. You can see each of those we have set the 8 factors differently, and we've got this final column, this peak height sum, which is our response. We want that number to be as big as possible. Throughout all of this, what we're trying to do is find the settings of these factors that make that number as big as possible. We always want that to be a big number. Now we've defined our response, we can talk about how we can use data in the best possible way to understand a process or system. Design of experiments isn't just about trying different possibilities and finding the one that works. One of the key values of design of experiments is that it gives you the right data to actually understand your process or your system. So you don't just understand what works well, you understand why it works well, you understand what happens if you need to change any of these settings at any point in the future. And we're going to jump now to demonstrate this. Right, so here we have our gigantic experiment. We have more than 4,000 different possibilities here. So you can see we've got 4,374 rows in this JMP data table. Each of these represents one of those different possible settings that we talked about. And for each of these, we have set up the large volume injector in this way. So we've set it with a volume of injection volume of 10, speed of injection to 0.25, injection temperature of 0, and so on. And then we've run the standard sample through it. It's created a gas chromatogram, and we have looked at all the peaks, looked at the height of each peak, added those heights all together, and we have this sum of peak heights. And again, we want this number to be as big as possible. That's going to enable us to test for very low levels of impurities in future samples. And we've done that for every single one of these 4,374 different possible ways of setting it up. So I've been able to do this ridiculously big experiment because I've got a large team of minions in an underground laboratory. Of course, I haven't really, what I've done there is actually to simulate the data. And if you're interested in that, let me know. You could maybe post a question in the community space for this JMP On Air series, and I'll let you know how I simulated this data. So I've simulated some realistic data. So we've got a realistic response for each of these settings that I've tested. I showed you a visual like this last week, where we visualized every single possibility that we've got. 4,374 dots. I don't think this is a very good visual, actually. I'm really showing it to give you a sense of the overwhelming size of this experiment and how ridiculous it is. I've colored it, so each point represents a single run, and the color represents how good that setting was. The settings with lots of big high peaks, big tall peaks, they're in green. They've got the biggest sum of peak heights. Those with a low sum of peak heights are in red. Now just take a look at that. Can you really make a lot of sense of that? Is it obvious to you what factor settings lead to good big peaks that are going to give us the best possible method here for measuring these impurities in water? And if you were just to randomly try different factor settings without a strategic way of doing it, what do you think your chances are of really learning anything? Now let's look at a better way of visualizing this. So this is the distribution platform. I'm showing a distribution plot here of the peak height sum, our response. And also of each of our factors. So that's the injection volume factor. We can see the 3 levels of that. You can either have it set at the high, medium, or the low levels of that. Now you can see that this visual is not static. It's interactive, it's dynamic. This is a really nice, simple way of learning from this data. So for example, you notice I click on this bar representing all the runs where injection volume was at its highest setting. I can then see the distribution of peak heights. I can do kind of the opposite of that. what I've done there is to select runs with a sum of peak heights that's you know, a higher one. It's these are our most successful runs, and I can start to see what settings of the factors those used. And if you take a look at that, maybe you can start to see some patterns. So it's looking like our best settings involve large injection volumes, which kind of makes sense. I think the analytical chemists would expect that. The speed of injection, well, it seems like a midpoint setting of that corresponds to the best peak heights. Similarly with injection temperature, it seems like using an injection temperature of around 0 is effective in giving us good big peak heights. And we can see that some of these other factors, like liner type, it doesn't really matter. It doesn't much matter whether I use type 2, type 1, I get much the same peak heights. Let's take another quick way of looking at that. Let's take volume of injection, and you see the 3 different settings we have of that factor, and we're going to plot the sum of peak heights. Well, now I can see that there is a relationship. We can see this positive relationship as we increase injection volume. We're increasing the sum of peak heights. I'll maybe just add a density plot there because we've got so many points we can't quite see where they're all clustered. You can see this, this smoothing plot that is giving us the trend. It's basically joining up the average peak height for each setting of injection volume. So the powerful thing here is that with just this very simple model, we're not only able to see how successful each of the settings that we tested was, we can make some estimate of settings that we never tested. We never tried an injection volume of 30. We are now able to make an estimate of what the sum of peak heights would be for runs where we set the injection volume to 30. This is again demonstrating how we don't just learn what's worked from the things that we've tried, we can actually learn about settings that we haven't tried. This is giving us a much richer understanding than we would get just from the kind of standard trial and error that we might utilize. Okay, let's look at some other factors as well. So I'm going to add in injection speed, injection temperature, injection depth, and so on. We could add all of our factors, and I'll just click done. And let's stretch this out a little bit. So we can simultaneously see the effect of more than one factor now. We can see that some of these factors look to be important. We can see that with some we have a simple relationship. With others, it's there's a curvilinear relationship between the sum of peak heights and that factor. So as we try highest injection speeds, then it improves the height of peaks. As we increase injection speed further to the highest setting, then actually that's giving us smaller peaks. That's a less desirable outcome from that experiment. So again, we're getting a really rich understanding now of how this system works, how each of these different factors affects the outcome that we care about. It's really pretty powerful. We don't get that if we just do standard trial and error, where we just keep trying things until we find something that works. This plot may look fairly similar to the last one. This represents probably our richest understanding that we can gain from this data. So we can see again, the relationships between our response and the factors that we've varied in the experiment. What's different here is that this is dynamic. This doesn't represent just the relationship between each factor and the response. It's simultaneously fitting all of our factors. And it's dynamic. So actually I can look to see what peak height I would expect for given settings. So I can change injection volume and see what peak height I would expect. We can also understand more complex behaviors. So just look at vent pressure and look at the relationship between our response and vent pressure. And what I'm going to do is change volume of injection. You can see that as I increase volume of injection, vent pressure has this very important negative correlation with our response. As I decrease injection volume, well, if we're running at very low injection volumes, then now vent pressure has no real important effect. This level of understanding you're only going to get from designed experiments. This is one of the key reasons for doing designed experiments. This is something we call an interaction. So this is another important piece of terminology for design of experiments. We say that injection volume and vent pressure have a two-factor interaction. The effects are actually interacting with one another. And these interactions are very common in chemical, biological, physical, mechanical systems. They're often missed when people don't use smart ways of experimenting. Often understanding an interaction in a process or system like this can make the difference between beating your competitor or not beating your competitor. They can really be that crucial. And you're only really going to get there by using designed experiments. Just so you know, if you look at the blog post that relates to this reason number 2 in the series, you can see that there's actually one of these prediction profilers for you to play with embedded within the blog post. So that relates to the JMP Public segment that we just had. So this is actually available to view in JMP Public, and there are some other visualizations that you can play with based on this data in JMP Public, and I'll put a link to that in the community space for this JMP On Air segment. So you've seen now how we can better understand a process or system using data from a designed experiment. Now, that was that vast, huge experiment using 4,374 runs. Now, most of the time, that kind of size of experiment is just impossible. It's completely infeasible. So what are we going to learn about next time? Well, we're really going to talk about efficiency. We're going to go back to the 26-run experiment that I showed you. And what we're going to see is how using models, visual and statistical models, we can learn much the same that we've learned from that ridiculously overblown 4,374 run experiment by actually just using a smaller experiment which uses 26 of those 4,374 possible combinations, so that you can learn and gain a rich understanding about your process or system, and you can do that most efficiently. And with that, I'll hand you back to Julian.
Outstanding. Thanks so much, Phil. And again, I'll invite everyone to visit our community page where you can interact with Phil about this topic and the upcoming topics. And yeah, thank you again, Phil, so much. Now, in our next segment, we bring back Artie Meidel to take us through another mindful moment. And we're not seeing your camera, Artie, if you're sharing.
I do. It says I'm unable to start video. It says the host has stopped it. Here we go. All right. Hello, everybody. My name is Artie Meidel, and I am the social media manager for JMP, but I'm also a yoga teacher. And so the mindful moment is a chance to practice mindfulness, which has 3 elements as I see it. So it's paying attention on purpose to the present moment without judgment. So we're going to practice that today. So to do this, come forward on your chair if you're seated, bringing your feet flat to the ground. And sit up tall. Relax your shoulders down softly. And then just look straight ahead at something in front of you, but with a soft gaze. So not a strong, intense gaze, just a soft gaze. Place your hands onto your lap. And then begin breathing in through the nose and out through the mouth. So a deep breath in and deep breath out through the mouth. Keeping the eyes open to begin with. So inhaling and exhaling. So each time you inhale, feel the chest expand. With each exhale, feel the body relax. Inhale and exhale. Inhaling and exhale. Now inhale one more time. And with this exhale, you're going to close your eyes and also close your mouth. Begin inhaling and exhaling through your nose. Deep breath in. Deep breath out. Slowing the breath down. And at the same time, deepening the breath. Keep breathing. Now begin to breathe normally. In and out through the nose. Eyes are closed if you can do it. Hands are on the lap. Shoulders are soft. And begin to notice where you feel your breath. Bring your attention to your nostrils. Do you feel the breath coming in and out? Now move your attention to the center of your chest. What do you notice there? Just be curious. Can you feel your heart beating? Do you feel the chest moving up and down with each breath? Just notice without judgment. Now move your attention to the back of your body. As you breathe, do you feel your chest moving up and down the back of your body, where most of your lungs are? And then bring your focus to your belly. As you breathe, do you sense anything here? And if you don't, it's okay. There is no right or wrong with this. Now place one hand onto the center of your chest, one hand onto your belly. And see what happens when you place your hands on these areas, and do you notice your hands moving as you breathe? Keep the shoulders relaxed. Couple more breaths like this, just breathing normally in and out through the nose, feeling the sensation of the hands on the chest and on the belly. Noticing your breath. And now place your hands onto your thighs and then gently open the eyes. Notice how you feel. Just for a second. And then placing your hands to the tops of your knees, we're going to do a little bit of connecting the breath to the movement. So the arms are straight here. Can't see my arms all the way, I realize. But I'm holding on to the tops of my knees. My arms are straight. And then with the inhale, I'm going to bring my chest forward, lift my chin, lift my head back. And on the exhale, round the spine, dropping my head and chin. So let's do that together. Inhale, lift the head, lift the chin, lift the chest. Exhale, rounding the spine, lowering the head, lowering the chin toward the chest. Inhaling. And exhaling. Now really let the breath lead the movement. So inhale, then begin the lifting of the chest. Exhale, and then lowering the head and the chin toward the chest. Inhale, lift the head, lift the chest. Exhale and lower and round the spine. Once more, inhale, lifting the chest, lifting the head. Exhale, round the spine. Then release the hands from the knees, bringing the palms back to the tops of the legs, the thighs, open the eyes. Pick up your shoulders and roll them up, down, and back. And let's do that with breath. Inhale the shoulders up. And then exhale, lower them down and back. 2 more times like that. Inhale. And exhale. Once more. This has been your mindful moment. Thanks so much for joining me. Stay curious and be present. Back to you, Julian.
Thank you so much, RT. Our next segment is Jump in Action. Here we're going to hear from Andrea Combs, who's going to take us through the Jump Tools menu.
Hello, everybody from rainy East Lansing, Michigan. As Julian said, my name is Andrea Combs. I'm a solutions engineer supporting Ohio, Kentucky, Tennessee, and West Virginia. And today I'm really excited to talk to you about Jump tools. So if you're new to Jump or haven't used Jump tools very much, let me first start off by showing you where you can find the tools. Tools are in their own special menu here. You can see there's a long list of tools here. Also notice I'm in a Jump table, and a lot of these tools are grayed out for me. So this is a pretty good hint that I'm probably not going to be using tools a lot from a Jump table, but rather I'm going to be using Jump tools when I'm in reports and journals. So over here on the left-hand side of my screen, I have my own little cheat sheet here for when and where I use JMP tools. First, we're going to talk a little bit about using JMP tools in reports, and then we'll talk about using JMP tools in journals. So let's start with reports. So let's say I have this report and I want to copy and paste some of these report elements either into a JMP journal or into a PowerPoint presentation. Well, I am going to use my selection tool. Now, aside from tools being up here in the tools menu, they are also here on my toolbar when I'm in a report. So I can come here and select the selection tool, and I could select this whole entire report. But let's say I'm just interested in maybe the figure and the summary of fit and maybe my ANOVA table. So I can select those separately by just using my shift key and selecting which elements I want. And now I can copy those by either going to the edit menu and saying copy or using Control-C. And let's open up a journal. So I'm going to go to File, New Journal. And now I have this empty journal I can paste over here. So now I just have those 3 elements I'm looking for. The other place I like to paste elements from a report is into a PowerPoint presentation. So let me go over to this PowerPoint presentation, and I have a blank slide. And my tip here is when you go to paste something from JMP, always go to Paste Special and use Enhanced Meta File. That will give you the best graphic for PowerPoint or Word. And you can see here, I have those 3 elements from my JMP report that I copied, but they're actually all in one image, which is really nice. So that's a way to copy and paste from JMP reports. Now in tables within your report, you may want to move columns around. This may not be the best example, but let me show you how to do this. Now we're going to go up and select our grabber tool, which is this icon that looks like a hand, and come down. Let's go to our analysis of variance table. As you can see here, I can select any one of these columns and move them wherever I want them here in my report. Now the grabber tool can also be used for rescaling axes. And before I use my grabber tool, let's go back to our default arrow tool because I want to show you something. So JMP can give you some tools automatically. So for example, here you can see I have my arrow tool, but when I come down over here on the axes, I automatically get the grabber tool. And if I move to the left-hand side of my axes, the grabber hand points to the left now. And now I can select and grab that and change my minimum value on my axes. Likewise, I can go up to the higher end of my axes. My grabber tool is now pointing to the right, and I can click and grab and drag the maximum value of my axes. Okay, I'm going to take that grabber tool back to the center now, and the hand orientation is pointing back up. And if I click and hold and then move to the left and right, you can see that I'm changing the scale of this axis, the min and max, although the absolute range of the graph is remaining the same. If I click and then move up, you can see I'm zooming in on the axes. I'm changing the min and max at the same time. And then if I do move it down, I'm zooming out. Likewise, I can do the same here on my y-axis, change min, max, and move this around. Now, if I go up here and get my grabber tool and now come into the contents of the frame, if I click and drag around, you can see the contents are being moved around, and I'm rescaling my X and Y simultaneously. Again, I am changing the min and max. I'm rescaling it, but the absolute range of the graph is staying the same. So that's the grabber for rescaling the axes. You can also use the magnifying tool, which is this magnify icon right here. So if I click on that and then click within my graph, you can see I'm zooming in around the point I'm clicking. And if I want to zoom back out now, I can use Control to zoom back out. And just a little tip here, if we go back to our default arrow tool, if your axes get to a place you don't want them to be, you can always come down and right click on your axes and say revert axes. So let's say I want to select some points in this graph. There's lots of different ways I can select points on graphs. I can start with my default arrow tool, and I can come in here and select individual points. If I want to select more than one at a time, I can use either my Control key or my Shift key and start to select multiple points here. The other thing I can do with my default arrow tool is draw a rectangle, and any points within that rectangle will be selected. And if we come back here to our data table, you can indeed see that I have selected those 30 points in my data table. But let's say, for example, I just want to select these points down here below my linear fit line. Now I could go through and use my Control key and select each individual one, but that would take a lot of time. A rectangle doesn't really get me there. So one tool that I really like is this lasso tool. So I can select my lasso tool and now come into my graph and very carefully draw a blob, a circular blob around those points, and now all of those points are selected. Lasso tool is good because you can do crazy figure-8 type shapes to get in and select individual data points pretty easily. Now the last tool for selecting points is a brush, and I honestly never really use the brush, but I'll just quickly show it to you. So the brush again is you're going to select points that are within that square on the brush. And then if you want to select multiple points, you can again hold down the Control key or the Shift key to select multiple points here. Now you can change the swath of this brush by using Alt. So if I Alt click and drag, it's going to now give me a much bigger brush here to pick up points. Now another one of my favorite tools is the crosshairs tool. And this is a good one if you want to estimate your X and your Y on a graph. So here's your crosshairs tool. I can select that, and let's say I want to know what the height and weight of this individual student is. Well, I can click on here and you can see I can cite in that individual data point. The area around the data point is magnified, and I get a temporary X reference line and a temporary Y reference line and the values, the approximate values here, because I'm not right in the center of the circle. But I can quickly see here that this student, their height is about 70 and their weight is about 172. So that's the crosshairs tool. The scroller is another one that I really don't use that often. It's good if you have really wide reports or really long reports and you need to scroll around those reports pretty quickly. And finally, for reports, the help tool, which is this question mark, always really good. Here I can click, for example, on this table, and it will bring up the JMP documentation around that particular report element. So here I have a summary of fit, which I can see a similar table, and I have a lot more information about what's included in that table. So that's JMP reports. Those are different tools I use in JMP reports. Now let's move on to journals. So journals can be a great way for you to save and organize your work, but they can be a little tricky to organize when you first start using journals. So I want to show you a couple ways you can use tools to organize your journals. So let's go back. I think I copied some stuff into a journal already. Here's that journal, and I'm just going to quickly add some information to this journal. This is a nice trick I like, where you can add all open files to your journal. So you can see here all of the data tables and reports that I currently have open. Now, I want to talk about what the default arrow tool does and what the selection tool does. So with my default arrow tool, if I come down here to the bottom of my journal and right click, I can add different things to my journal. So let's say I want to add some text items here. Let's say, for example, I'm worried that in big class, there could be a possible outlier. And for big class, I want to make a note that this is the 2019-2020 school year data. And then for US demographics, this is a data set I'm going to want to send off to my manager when I'm done. So I'm just going to make a note for myself to remember to send to Mary. I know she's waiting for this one. Okay, so now I have those individual text items, and whenever you add an item to a JMP journal, it's always going to be added to the end. And a lot of times you want it to actually be further up in your journal. So you can use the selection tool, and actually I'm going to hover over the arrow tool, and you can see here there's an A in parentheses, and in the selection tool there's the S in parentheses. And those are both the keyboard shortcuts to get those tools. So a lot of times when I'm in a JMP journal, I'm toggling back and forth between A and S. So for example, I can come here and select some stuff about my big class data set that I want to put up here. Those two notes are for that data set. This note for here is for my US demographics data set. And then let's say I want to get these report elements underneath big class as well. So I can scroll down here to big class and get those where I want them to. So again, the arrow and the selection tools are really good for organizing your journals. You can also annotate in your journals. This is the text annotation. So let's say I want to make a note about this data point being the possible outlier. So I can put possible outlier in this text box. I can change different things in here, like the background color, for example. And if I want to really make it evident which point I'm talking about, I could add a line here and change it to a 0.2, which changes it to an arrow. I can make it thick, I can make it a different color, lots of different options. You can also add shapes. You can add polygons or simple shapes. So for example, if I really wanted to call out the R squared, I could put a box around it. I could change the shape to an oval. And let's say I want to make this red so it really sticks out. And again, in JMP journals, you can also use the help tool to open up JMP help. Now, last thing I want to show you about JMP tools is where you can find out more information about JMP tools. You can find out more information in the menu card and the quick reference guide under the help menu. I really like the quick reference guide because it includes the icons for both Windows and Macs all the way at the bottom here. So you get the Windows icon, the Mac icon, the shortcut, and a brief description. So that's all I have about JMP tools, and I'll send it back over to you, Julian.
Outstanding. Thank you, Andrea. That was such a great overview of the tools menu in JMP, and such an important thing because a lot of people miss the functionality of all those different tools. So really quite fantastic. Thank you so much. So in our final segment, we're going to hear from Ryan, who's going to take us through comparing data tables in this week's or today's Have You Tried?
JMP can compare two open data tables and report the differences between scripts, table variables, column names, column properties, column attributes, and of course the differences in data. For this demo, I created these two data tables from the phishing sample data in JMP. Let's see if we can discover the changes I made. To compare two data tables, have them both open in JMP. In one of the tables, select Tables, then Compare Data Tables. If necessary, select the data table that you want to compare from the list. Before we even select the Compare button, in the Table Info section, we can see that the amount of rows differs, but they both have 8 columns. Click the red triangle and select which items that you want to compare and how to show the differences, and then click the Compare button. Under Data, the difference summary and difference plot are shown by default. Additionally, any red triangle options that you selected will also appear. The interactive difference summary report and the difference plot indicate how rows differ between reports. Each entry in the difference summary report shows which action occurred and how many rows were affected, and the first row in which the change occurs. The reason the plot is vertically long is that the gray area indicates that no differences were noted. Colors indicate where and what type of difference was noted. The first action entry noted that row 1 was replaced and highlights that row in the data tables. The second entry is that I added a single row after row 2. And the following difference noted was that I deleted 2 rows, row 8 and 10. When you select the entry in the difference summary report on the left, the entry highlights in yellow and the row flashes in the data table. For a graphical view of the comparison, place your cursor over a colored cell in the difference plot. Click the previous difference and next difference buttons above the difference summary to navigate from row to row. This is a very brief introduction, and I've linked a tutorial that you can follow below. I hope you find the JMP Compare Data Tables tool useful in an upcoming project.
Fantastic. Thank you so much, Ryan. And we definitely invite you to try Compare Data Tables. It is outstanding when you have multiple copies of the same file over time and you want to see what changes maybe you or a colleague have made. We're really glad you joined us today for our JMP On Air broadcast. Make sure to interact with us in the JMP community, community.jmp.com/JMPOnAir. You can watch all the past episodes, recordings from today's segments, or share it with colleagues. Make sure to follow us on all the social channels. Check out the program guide. We have some great talks coming up this week, and so we really hope you'll join us. Share us with a colleague. JMP.com/JOA is the link to share. That'll take them to the program guide and let them subscribe for themselves. We hope you join us Wednesday, but until then, we hope you stay safe. We hope you stay healthy. We hope you stay close, even if you're keeping your distance. Take care, everyone.